Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for the 451 Research arm of S&P Global Market Intelligence, and today we will be discussing data center sustainability with returning guest, our Principal Research Analyst, Dan Thompson. Dan, welcome back to the podcast.
Thank you. It's great to be back. Always good to be on the show.
Well, and great to have you back and to really, I think, continue a conversation that we've been having on an ongoing basis. We've talked a lot about what's happening in perspectives around sustainability, but there is more that is happening just recently. There's, well, one on the research side. You've just come out with a technology and business insight around data center sustainability that brings together a whole set of perspectives, and we're starting to meld together information across what's, the whole breadth of S&P market intelligence capabilities. But there are also other things that are coming to bear that I think are maybe stepping up some of the conversations around sustainability. And before we get into some of the technology aspects, I wanted to really touch on the focus of really what is driving interest in sustainability, and are there things that have taken that up a notch recently?
Yeah, I guess when we think about the sustainability of the data center industry, it's a correct observation that this conversation has really ratcheted up over the last couple of years. And to your point, there are a bunch of different influences for that and drivers for that. And what I would say is, what we're seeing right now is sort of a perfect storm of influences. We have a series of government regulations kind of playing out globally, and that's as governments decide what their climate goals are and what the year markers are for those goals. They then turn to industry and say, okay, we're going to do our part, you need to do your part. And so that's one part of it. Another influence here are customer influences. And so again, these are customers of data center providers who have made climate type goals. And then, here again, they're looking at their supply chain saying, okay, here's our goal. If you want to do business with us, we would like for you to meet these goals as well, or help us meet our goals in the process. And then, we're also seeing influence from investors. So there's a number of green financing options that are available today that are relatively new. Just past couple of years new, really past 18 months new. Which allow companies to get lower costs of capital if they will meet certain metrics.
Looking at green bonds and the ability to be able to look at what is embodied carbon for the entire footprint of the system. And guess what? Data centers are pretty capital intensive.
Yeah, that's right. Yeah, and so kind of coinciding with that, a number of organizations, S&P included, are now giving out or assigning rather ESG scores to companies, and that's kind of folding into the investor equation. It's also worth pointing out that there's some societal influence here as well, whereas just broader society is saying, hey, we need to do things more responsibly, we need to do things more sustainably. I would suggest and perhaps argue that that plays out in the data center industry in the form of customer influence and investor influence, because at the end of the day, if your brand does not have a good image, you're going to lose customers, you're going to lose investors, right? But that's generally what's driving this conversation today.
Well, and you're pointing out advances in the regulatory sphere, and it seems like a lot of what we're identifying is that now, the regulatory bodies, governmental agencies, now are looking to be able to identify some specific metrics around efficiency. They're now starting to actually require specific performance capabilities. We talked in previous episodes about what was happening in the Asia Pacific region and how a number of governments were starting to regulate that. But now they're actually coming out with specific targets around performance.
Yeah, that's right. Yeah, we've seen this play out globally, really. In Europe, they were probably the first to do it with different regulations. And now you see country-specific ones where countries are requiring very specific PUE measure, or that's power usage effectiveness or efficiency, and other metrics. China is doing this as well. Singapore is working on new regulations that will likely include some sort of efficiency measures. And so essentially what these governments are telling the data center industry is you need to clean up your act. You need to be as efficient as possible, i.e. Have less strain on the public infrastructure. And then increasingly, they're also asking data center providers to source green energy as part of their play in those individual countries.
So we've talked a little bit about PUE, and people are also now talking about WUE. But I'd like to dig into these a little bit because a lot of our audience is probably not familiar with these measures and what they mean and what this really means in terms of assessing efficiency in a data center.
Yeah, let's dig into that actually. So PUE, I mentioned it just a second ago, power usage effectiveness or power usage efficiency. You'll hear those kind of intertwined. But in any case, what PUE is essentially a ratio of how much energy a data center uses beyond just the IT load. And so just to use quick math here and easy numbers, let's say you have an IT load of 1 megawatt. If your data center requires an additional megawatt to both cool and just run the building, then that would give you a PUE of 2. So we need a megawatt for our IT load, and we need yet another megawatt for the cooling systems and everything else. And a PUE of 2, unfortunately, is still a fairly common thing these days. One of the things that we've seen in our research, other companies have echoed this, is that PUE has been somewhat stagnant over the last decade, really. More efficient data centers, you'll hear PUEs like 1.5, 1.3, increasingly 1.2. So we're really driving that PUE number down. And so, here again, what we're saying is if my IT load is 1 megawatt, I only need a half a megawatt at a PUE 1.5 to keep that cool and to do the other operations of the building. It is a bit of a slippery slope. Unfortunately, PUE, oftentimes the numbers you hear thrown around are the design PUE, meaning that if my data center is 100% full and if it's operating optimally, then I could hit a PUE of 1.2 or 1.3. And you heard a lot of ifs and a lot of coulds there, right?
Yep.
And so the question, go ahead.
Oh, I was going to say that's an important point because as you're identifying, if the data center is 100% full, then your IT load is at its peak and all the energy you're using in cooling, all the power it takes to run the chillers, all the pumps, all the fans, all the everything else hits its maximum for the ratio for IT. But if you haven't filled out the data center, if it's not completely occupied, you've still got all of that, chilling and management and everything else it's running, and that hits your total percentages because your IT load number is lower, but your overall operational load for the facility itself is still going to be at the same level it was. And granted, it's going to, chilling, refrigeration requirements are going to increase with increased load. So if you aren't all the way full, you don't have to cool quite so much, but still you've got all that overhead and less efficiency just because you're not 100% full.
Yeah, that's right. And I would suggest that in the enterprise segment, it's very, very rare for those data centers to ever be full and ever be operating at optimal capacity. I would further suggest in a multi-tenant data center environment, it's at least more likely that they would hit that, but also still rare because customers come in and they said they needed, 100 kilowatts, and it turns out they only needed 50. Well, you as a data center provider are contractually obligated to be able to handle 100 kilowatts. And so you've got to have it sitting there ready and waiting. But, because your customer, it turns out, didn't actually need that much power, you're kind of stuck, right? And so there's all these sort of weird nuances that kind of play out in data centers that are holding those PUEs up higher than what we would like for them to see. But that's all well understood. I guess what is not as well understood, I think, is the WUE. PUEs, much harder to pronounce brother or sister, is WUE. And so what WUE is water usage effectiveness or efficiency. And so what this is a measure of how many liters of water a data center consumes for every kilowatt hour of energy that it consumes. And so just to kind of talk numbers again, so the U.S. Department of Energy has done some surveys, and they estimate that the average data center consumes 1.8 liters of water for every kilowatt hour of energy consumed. So what in the world does that even mean? So back to our 1 megawatt data center example, that works out to 464 gallons of water per year that a 1 megawatt data center consumes on average.
And your average data center is significantly higher than a megawatt.
Exactly what I was about to say. Yeah, I mean, we're dealing with easy numbers here, like tens of millions of gallons, hundreds of millions of gallons. Like these are easy numbers to hit from data center perspective, because we're not talking about 1 megawatt data centers anymore. It's 10 megawatt data centers, it's 50 megawatt data, it's 100 megawatt data centers, right? I mean, like these numbers have gotten so crazy at scale that the amount of water that's being consumed is pretty wild, actually. Now, the kicker here, though, is that depending on where you live, probably dictates or at least influences how much you care about this. And this is causing a little bit of an issue in the data center industry. The other thing is that WUE is a fairly new metric that companies are adopting. And so there's not really an understood and accepted good number. So like with PUE, for example, like if you and I were to sit down and we were talking about a data center, there would be no disagreement that a PUE of a 1.3 is a good number. But if you and I sat down and said a WUE of 1.5, is that good? Is a PUE of 0.8, or excuse me, WUE, is that good? You know what I mean? Like, so there's just no industry accepted. Because environmental changes or environmental differences, you know, in some places it's hard to use water evaporation, whereas in other areas of the world it's not hard to use it. So let's kind of dive into that just a little bit. So some cooling systems use evaporative cooling, which is essentially like, if you're familiar with home cooling, like a swamp cooler, like you see these out west a lot, whereby they're essentially evaporating water as a cooling mechanism.
And in dry climates, you can get pretty efficient in terms of evaporating the amount of energy you can suck out of something through evaporation, because if it's dry, easy to do.
That's right. The unfortunate part of that is what you just said. It's in dry climates where this works really, really well. It's also dry climates, I probably don't even need to say this, that don't get a lot of rain.
There's no water.
Right, exactly. Yep. So this becomes an issue in, like, for example, here in the United States, in the desert states, like you're seeing tons of pushback from community over the amount of water usage. I mean, like, how many articles just in the past couple of months have you seen about Lake Mead being low and Lake Powell being low, right? I mean, like, these are major issues for our western states in that the water supply for electricity generation and consumption is rapidly disappearing, right? Just this past week, though, I mean, just to kind of put this on scale, just this past week, Death Valley National Park was closed because it received torrential downpours. They got just shy of 2 inches of rain, and it's like biblical level flooding.
Well, and Death Valley, right.
Yeah, here where I live, which is in the southeast, last month we got just shy of 19 inches of rain. And like, that's just July. You know what I mean? And so it's like,
just regular expectation about what you're getting, but well, and it speaks to a lot of these impacts of changing climates and what this means. But there are these fundamental issues we've got to get over. And you probably can't count on Death Valley getting 2 inches of rain every July.
Right.
Unlike other parts of the country where water is more plentiful and it's less of a concern. But
exactly. Yeah, it's like, so what's the trade-off, though? So there is a trade-off here between WUE and PUE. So what we found from our research is that by using more water, so by like letting that WUE number climb up, we can drive our PUE numbers down. And the average decrease that we found with our research is a 0.15 to 0.2 decrease in PUE. Now, that may not sound like much, but when we're talking about a 10 megawatt data center, That's a megawatt and a half or 2 megawatts of power that I didn't need to consume, right? Just because I use more water. And so like that's not an insignificant number. Now also, like, don't forget that when we're talking about energy usage, we're talking dollars here, right? I mean, like that's financial savings that a data center company realized by using more water as opposed to using a refrigerant, which requires more energy. So there's a trade-off. And what I would suggest that what we're seeing is start to play out anyway, is that in the Western states, for example, here in the United States, companies are starting to come around to this idea of, okay, I'll take a hit on PUE for the sake of lowering my water usage.
And now we've got one more complex equation that we've got to solve to be able to balance what is the overall consumption to what is a broader perspective on sustainability. Right. A lot of different things that have to be balanced and complex decisions to put in place around this.
Yeah, no, that's exactly right. And what I was going to say is here in the Southeast, we don't even see that conversation really coming up. There's been some isolated events, like in South Carolina, this came up. But in any case, like we don't see that conversation as much. What I would suggest, though, is what you were just hinting at, which is that just because a resource is plentiful doesn't mean we should be wasteful, right? Like we should still be good stewards of what we have. And so, we should be considering this, but maybe we adopt a stance of, in the Western states where water is not as plentiful, we accept that PUE hit. But maybe we put more workloads in the Eastern states where water is more plentiful, and we lower that PUE. And we have to come up with some sort of balance here, where we're saying, okay, maybe the Eastern states bear the brunt of water usage while the Western states consume more energy. That does create more problems, though, right? Because the Western states, while they have been moving to more renewable energy sources, they're also, it's common to hear in the news that they're coming up short as far as energy generation is concerned. So there are lots of things to wrestle with it. Like this, like as every problem that we see from a society, it's complex, right?
Well, and we haven't even touched on what I think is that bigger picture, but this is sort of where we're headed, which is overall efficiency of the data center itself. And there's so many dependencies that get tied into the actual applications that are running in the data center.
That's
One of the other things that you're getting into in the report is talking about this balance between reliability and sustainability.
Yeah.
And the fact that what is that next step of, okay, you've got to keep all this stuff up and running. You've got to keep it reasonably reliable. So now you have to throw into the mix backup capabilities, because you're talking about, hey, you've got grid power and hopefully you've got access to renewable power in your grid, but the backup power you've got for effectively all of the data centers that are out there today is really not very sustainable because most of it is diesel generators.
Yeah, that's right. Yeah, and this has been sort of an interesting conversation that's popped up over the last 16 to 18 months as there's been a lot of pushback around the use of diesel generators. Now, kind of an interesting side note here is that the hyperscalers, several multi-tenant data center providers have come out with numbers, and they're estimating it's about 1 to 2% of their overall emissions are associated with the diesel generators running their data centers. So that's a small number. However, as we chase out the carbon from our energy sources, meaning that like the electricity that's coming in the data center, as we chase out the carbon of that, suddenly that remaining 1 to 2% gets to be a real challenge. Like I've heard commentators from the hyperscalers saying getting to 95% renewable is fairly easy. It's that last 5% that's really, really hard to chase out. And that's when we get into this conversation about these generators. So the problem today is that there's just not a good alternative to diesel generators. You've had companies look at natural gas generators.
I mean, there's fuel cells that people are experimenting with,
That's right.
Hydrogen fuel cells, but it's at the experimental stage.
That's exactly right. Yeah, we have distribution of resource issues when we talk about natural gas or when we talk about hydrogen. Most of the hydrogen fuel cells that are out there in experimentation today are using natural gas. So we haven't gotten to a perfect solution, which I believe is okay. it's okay as long as we're making steps in the right direction. The industry typically pushes back against that, though, and wants a perfect solution.
Well, but here's the point at which we're maybe, is the perfect the enemy of the good in this, in that it's this question we've been having for I don't know how long, which is this battle between reliability and sustainability. And I'll make the case that we've had this issue of the applications that are running in the data centers are abstracted away from the nature of the data centers themselves. And because of that, we get into the situation in which people building applications say, oh, the data center has to be fully reliable because my application needs a reliable infrastructure to run on. If we could turn that conversation around and say, well, the data center itself may or may not be reliable, and realistically, data centers aren't perfect. We've got however many nines you happen to have.
That's right. That's
even
right.
Big cloud providers are 99.95% availability guarantees that are out there. So you should be planning on some level of failure, but invariably, anytime we get into any kind of failure in an environment, somebody's planning for recovery from that failure scenario is imperfect. Things go down, services crash, stuff is unavailable.
Mm-hmm.
But maybe I guess do we ever get to a point at which we have less than highly reliable data centers? We had that discussion, I don't know, years ago, probably a decade ago, about the idea of whether or not two tier 2 data centers, at lower levels of reliability, could actually, when paired with correctly built applications, operate as well as a tier 4 data center, in which everything is redundant,
right,
and doubly redundant.
Right.
And that back in the day was just sort of a horrible conversation. People say, oh no, we can't possibly do that. But
yeah, I'm definitely not weighing into that. But
well, right, yeah, it's that's like 4 or 5 more podcast episodes. But if we had applications that had less dependence on high reliability data centers, maybe there's some things we could do on that front as well. But
yeah, no, I mean, I think it's a worthwhile conversation. I mean, one of the solutions that is being sort of suggested these days is, what if we got rid of the diesel generators and then just used extra batteries? So one of the hardware manufacturers today is pushing this idea of a 4-hour battery. So let's say we're back to that 1 megawatt data center. We would have enough battery storage there to be able to run that data center off battery for 1 hour, for 4 hours.
Today, batteries are going to give you enough time to get the generator fired up and online. So
right.
On the order of like 15 minutes-ish, sort of thing.
That's right. And so this would be replacing the diesel generators, putting in batteries in place to hold that facility up for 4 hours. 4 hours gives you plenty of time from an infrastructure perspective to shift workloads to somewhere else. Obviously, there's some physics problems here. You would need those data centers to be close by, depending on how much data needs to traverse back and forth. But all that being said, like, technology exists to do this today. We have the orchestration and automation to do this today. We've had it for years. But to your point a second ago,
but how many people have actually put it to work? Well, and we were talking about, even within data centers, you've got redundant power supplies. You've got, even within an individual rack, you've got backup power, but you have to make sure that you've got an A side and a B side power supply, and the data center provider guarantees that at least one of them is always going to be up. But you have to make sure that the people running there have actually plugged the servers into both of those different power supplies.
Right.
That they've got redundant power supplies in the servers that they built. All these things that we get into these chicken and egg problems of, you have to have people using these systems. You have to have people leveraging those capabilities in order to make this practical.
Yeah, that's right. And I still hear data center providers saying that they've got customers that, for whatever reason, didn't plug in their servers to A and B side, or they're using switches that don't have multiple power supplies, and so they can only use A or B. Just in the same way that, like, every time we hear of a public cloud outage, there's some prominent company who goes down, right? It's simply because engineers didn't program in redundancy to some other region or some other, availability zone that was not affected by the outage. And so it exists.
Gets back to the application architectures to get, right. You got to build it so it's resilient.
It's hard, man. It's hard. It's not.
No, I'm not saying it's simple, but
yeah.
But this is, these are concepts and ways of doing this, that there are answers to this. People just have to put them to work. And
that's right.
And hey, like a lot of things in tech, it takes time to make this work. And it takes thought, it takes effort, it takes, and that's expensive, and people have got to make that effort to make it happen.
Yeah, no, that's absolutely right. And I think one of the things that you're speaking to just quickly is we really have to stop thinking of our IT infrastructure in silos. Traditionally, the way we thought about this is the building people worry about the data center, the infrastructure people worry about the infrastructure. We have to start thinking about this together and working on this as a problem together, and not seeing of it, it's a building problem, it's an infrastructure problem, it's a solution that we need to come up with together.
And it's all of these pieces that have to mesh together. Granted, I think the thing we keep returning to over and over again is these are complex issues, but if we work across organizations, these are things that we can address. And that if we want to look at sustainability more broadly, we've got to look at approaches that are going to bring together lots of different perspectives, are going to integrate all of these different aspects and make more intelligent decisions about how we move across these organizations and how we get all of these things to work together and mesh efficiently and effectively.
Yeah, that's right. That's right. A mode of continual improvement. Like that's what we're after here is don't try to boil the ocean tomorrow, right? We need to make one step today, one step tomorrow, and then all move forward together to a more sustainable future.
I think it's the hydrogen folks that are trying to boil the ocean, right?
Right.
That's not us. No, that's not what we're talking about here. Well, speaking of boiling the ocean, Dan, there's so many other things we could dig into around this. Once again, we're going to have to get you back to dig into this in more detail. I will point our listeners towards the data center sustainability study. It's out on the site. You can get the executive summary by just clicking on the links for it. We'll actually have links in the show notes. I hope that you take a look at it. And again, to bring people together to talk about this and come up with better integrated, more intelligent ways to be able to do this to really manage sustainability. As we've been saying, the opportunities are out there. We just need to put our heads together and make it work. All right. Well, thank you very much, Dan. That is it for this episode of Next in Tech. Thanks for being back, but we'll have a rain check to have you back on.
All right. Yeah. Thanks for having me. It's been a wonderful show.
And thanks to our audience for staying with us. And I also want to thank our production team that includes Carolyn Wright, Katerina Iacoviello, Ethan Zimmon, our intern, Michael Asaolu, and on the marketing and events teams, and our studio lead, Kyle Cagnolosi. I want to remind our audience as well, it's time to start thinking about 451 Nexus, our conference in October. We're going to be back in person in Las Vegas. We are going to be kicking things off with a keynote presentation from Margot Lee Shetterly, the author of Hidden Figures, who's going to talk about all of those, or the human computing aspects that drove the U.S. space program and a lot of the computers, the people computers at Langley. So join us then. I hope you'll also join us for our next episode, where Ian Hughes is actually going to be back talking about augmented reality and virtual reality, and a lot of the aspects of where that fits in tech, the idea of how this integrates with the Internet of Things, and maybe being a front end to a lot of the things we've typically done in that area. But I hope you'll join us then, because there is always something next in tech.